Welcome to Bold Assumptions Article Roundup. This week we're going to be focusing on water purification techniques. The first question I'm going to start with is, why is access to clean water such an issue if over 70% of the earth is water? According to National Geographic, only 2.5% of this water is actually drinkable, and of that, only 1% of it is actually accessible for us. It's almost kind of ironic because we have this huge planet which is mostly water, but of that we can't even have enough to feed the species enough water to survive. One of the first areas this points to when thinking of the clean water crisis then is the ocean. Like, why aren't we just taking water from the ocean and drinking that? The ocean, is basically a place where most rainfall, ice melt, and runoff ends up. It's basically the great basin of the whole planet where all the water will eventually end up. So why then is it so difficult to purify? Or even on that, why can't we just drink it in the first place? The first fact to point out is that because of the high salinity or presence of salt in the water, if you were to be drinking ocean water, you would basically be drying out your body faster than you're hydrating it because the salt acts in such a way that it's more so drying out your body. The shortcomings of purification that we'll later point out further on in the video is the fact that it takes too much energy and too much money to go through with these purification techniques. The leading form of water purification today, mainly for the ocean, is something called reverse osmosis. If you were to read the side of any water bottle, you'd probably see that it says purified through reverse osmosis. So what exactly is reverse osmosis? According to the National Water Service, it's defined as a technology which puts an immense amount of pressure on water and pushes it through a series of filters and semi-permeable membranes, which, through all of this, the contaminants can be filtered out. Basically, as the water is pushed along through at such high pressures, the filters get smaller and smaller as they go through, basically so they can catch the bigger contaminants at first, move along until they finally only the water can get through. This purification technique, it's one of the leading purification techniques that we use today, and it seems almost perfect. So what could be the catch? The catch, as hinted at earlier, is because of its immense energy and cost that it takes to do. According to Energy Central, the one plant alone in California costs over $1 billion. And this figure alone can scare away many countries from doing it. And that's even thinking about the fact that the countries that usually need the purified water probably don't have that much money to be throwing around anyways. Energy-wise, it can get even worse. With billions of gallons being pushed through these filters, it could cost as much as 10 to 13 kilowatt hours of energy to push even 1,000 liters of water. The average U.S. home can be powered off 900 kilowatt hours of energy. So when you put this into perspective, it could, only 90,000 gallons of filtered water could end up totaling the amount of energy that it would take to power a whole home. When you put this figure in perspective of, the bigger picture, the fact that billions of gallons of water would be being processed, that's so many homes that could have been powered, especially in these areas where you need water. There's probably bigger issues with the energy crisis there than the water anyways. So you have to balance all these figures, and it comes to a point where it may just not be worth it using these types of purification techniques that we use today. And even if we ended up just using solar panels to power this, you got to think about how inefficient solar panels can be. So with that, you would have these huge fields of solar panels powering these water things, and it would just take way too much land and usable space. All these faults make you wonder, what is the actual solution then? Many researchers and companies are looking towards graphene related solutions where filters that are made of graphene are able to push more water through at the same energy cost, so that therefore you're saving energy in a way per gallon of water. According to Fast Company, a group of researchers in Australia is doing just that. Rather going through the grueling process of high pressure water going through all these series of filters, this researching group, they're trying to make it to where it only has to go through one filter, and after that it's clean. The question this raises then is, how does it work? And the way it works is through a close relative of graphene called graph-air. On the molecular level, the way this works is there's basically these really small channels which only pure water can fit through. No other contaminants or particles can get through there except for pure water. So with this, they're able to completely stay away from the Goliath that is reverse osmosis, and which has been, completely dominant in the world of water purification, and they get to go through a new process called water distillation or membrane distillation. And basically what it is there's a temperature differential in the clean and the dirty water, and then, it goes through the filter, and the graphene filter, and it's able to get clean again. The hope, they say, is to be able to use solar panels which can heat up the dirty water. Therefore, it's able to be, the temperature differential is able to be met, and the dirty water can feed through and become cold again. Early experiments and studies have already shown that if you have 2 or 3 of these films the size of about, a sheet of paper, you can filter an entire household worth of water. So on a larger scale, if you want to filter whole communities, it really doesn't take that much surface area of this film to be able to do that. In the future, they're planning on working with these other companies to make water bottles that you can drink from that automatically filter and stuff like that. But the huge goal is ultimately to be able to make graph air more accessible through different processes of harvesting it, and also just make the technology as a whole more accessible for everybody. With the leaps and steps they're making, it could be very, very soon that we're seeing these on the market. And obviously, their main goal of the research group is to give them to, lower impoverished areas where they don't have access to clean water. So I don't know if it's more like a donation kind of thing or a business model, but either way, they're trying to help save the planet with access to clean drinking water. And I love that researchers are more so focusing on cleaning the ocean's water rather than sticking to like groundwater that most people do with, say, for example, the Life Straw and stuff, because I feel like it's just such a huge untapped area of water. Everyone always looks to, okay, why don't you just check out like nearby lakes and streams and try to purify that? But the ocean has so much water, and all water, could eventually one day lead to there. With the glaciers melting and everything, this clean water that you could have got through the glaciers is now being contaminated by salt water. So you need to find better ways of converting salt water into drinkable water, because one day that could be our only method in getting water. Anyways, it's been Bold Assumptions, article roundup.